All right, so the next video in this series is the scientific method. All right, I'm not going to spend too much time on this. I'll let you read into this in a little more detail if you'd like. But really just trying to hit the general theme here, which is scientific method is a process, right? It is not something that is end all be all. It is not some sort of like magical entity. It's just a process, right? And it is an inductive method. All right. So what that means is you're going to make many observations, and throughout that process, you're going to make many different generalizations, predictions, and you're going to test it out, right? So, for example, you got to find a problem, right? Whatever that problem is, and then you're going to come up with an idea or a hypothesis that you can test to try and better understand that problem, right? So, an example right now, this is very general, but maybe one in the world could be vaccinations, right? That's a big one with a lot of people. The scientific method is the process of, are they working? How do we know? Well, you got to test it, right? So, my hypothesis is if we provide individuals with vaccines, they are people are less likely to have to go to the hospital if they get COVID-19, right? So you have to come up with a hypothesis like that, which is testable. And that is the most important part of the hypothesis and of the experiment. It has to be testable. You can't just come up with an idea that you cannot actually test. If we do that test, we have to create a proper experiment, really. You have to have the correct design behind it. There are many ways to make a practical design for your experiment, but there are some things that are important. It's got to be a large sample size. If I'm talking about the vaccination, are you gonna trust someone who says, "Hey, I tested 10 people and no one had any side effects," or see, I'm doing the faces. I think you know where I'm going with this. Or would you rather trust someone who says, "Hey, I tested 100 million people. That's pretty significant. And here are my results." Numbers are a big deal, right? The more you have, the more solid your results are going to be. With that said, you also need control groups. A control group is a group that's going to receive the same conditions, but without, as you see here, without the variable being observed. For example, my variable that I am observing would be the vaccine. So I would have one group getting the vaccine, one group not getting the vaccine, but still testing them under the same conditions, right? So let's say I have 100,000 people in New York and I have 100,000 people in New York, right? They're still living their normal lives and doing their thing, except half of them will receive the vaccine, half will not. That can be as simple as just telling people, hey, you're not getting the vaccine, right? Or we can do something called a placebo, where you can give someone the vaccine still, but it isn't the vaccine. It's just a what's known as a sugar pill, right? You're going to give them what they think could be the vaccine, but they don't know if they got the real thing or not to test it out. And that's important for other for depending on what you're testing. That's what I'm trying to get at. Sometimes a placebo is necessary. Other times you may not need it. And then there's different types of tests. You can do a single blind. You could do a double blind method, so on and so forth. The point is, you have to make sure your experiment is designed correctly. After all is said and done, in scientific journals, we're going to see peer review, which means that we're going to have other professionals read through the literature, right? They want to make sure that's right. It's going to be peer reviewed to make sure that everything actually makes sense, it's done correctly, and it's not going to be faulty data. And it prevents people from going in and just being like, an example could be that I have bunnies living in my head, right? Little invisible bunnies that live in there. My test was that I looked in the mirror, I looked really hard, and I didn't see any. So I think that I don't have any bunnies living in my head. But my buddy walked in and saw me looking in the mirror, and he asked me what was going on. And I was like, I think I see bunnies. And he's like, whoa, I think I see them too. Whoa. So it's got to be real. So I think I have bunnies living in my head because my friend saw it. Right? Yeah, it doesn't make any sense. But without peer review, you'd be surprised. Maybe not that kind of scientific practice, but other types of scientific practices could be published. And a very famous one was one where someone said that vaccines, because we're on the subject, cause autism, right? And that was a paper that was not peer reviewed. And with that said, it left a major impact on people's sight in the way they see vaccines to this day. And that paper was based on very little, no evidence really, in faulty science, faulty data. So with that said, peer review process is significant, and we need to make sure we do that. And then the rest of this, you guys can read through, better understand facts, laws, and theories. And this is just really important for understanding basically where does science come from and what does it really mean. Um, so check that out.